It's 2025 and the way we write code has changed. Are you writing most of your code by hand or are you leveraging AI coding assistants? I've noticed that a bunch of my colleagues either aren't using them or they're using them ineffectively. Hi, I'm Jeff Chaumet and I want to share with you some techniques and some tips that I've learned over time to get the most out of my AI code assistants. You might take these for granted, so I want to share a story with you. I was on a plane once and I wanted to work on some code. I pulled out my laptop. I didn't have any Wi Fi, of course, so I couldn't connect to the AI providers, but that was fine. I could just write my code. And I had a strange experience. I noticed that it was just kind of hard to write my code. It was very meticulous. It was kind of cumbersome to just get like all the parens and move the code around. Stuff that I've been doing for over a decade, never had any problem. But in about a year's worth of using these AI coding assistants, they fundamentally changed the way that I write code without me even realizing it. Once I saw that, I knew that this was worth paying attention to. So these aren't coming to replace us. They're actually just tools that make our jobs easier. And just like any tool, the better you know how to use it, the more it's going to help you. So let's dig into them a little bit more. First thing you have to know about your tool, of course, is what can it do for you? What are the features? And there's the obvious ones. There's like code completion, there's code editing, there's code explaining, there's code searching, and then there's some more advanced ones. Like for example, why doesn't the editor just know where I want to go next and just put my cursor there? Why should I do that manually? Or I fix something on one line. Why doesn't it just fix it on the line above it for me as well? Why should I have to go manually do the same thing again? Or I change the signature of a function, just like make everything work for me. Why should I do that myself? And sometimes, sure, an IDE can do this for you, but for a lot of things, it can't. And that's where some of these power features are helpful, and not all of the options have them, but many do. And the one that I personally like to use is Cursor, and I use the Claude Sonnet model with it. So that's what all this is based on. So you got to know what features it has, and you got to actually use them. Once you know what your tool can do, you have to know what it's good at and what it's bad at. And so, in general, what I found that these AI assistants are really great at is just writing code, like actually formulating code correctly. They do just fine. In fact, they're even like more accurate and quicker than I am manually at like matching parentheses and digging into a deeply nested data structure and indexing and off by one errors. They just handle that so much better than I do by hand. So definitely relying on that. Also, anything that has to do with a pattern. So variations on test fixtures, your tests themselves, or repeating like a similar piece of code for a different case. Anything that's pattern based, they're great at. What are they like okay at? Well, knowledge and reasoning. So they know a lot about, different languages, frameworks, tools, and even approaches and coding concepts, design patterns. They've got that down. And sometimes they apply them correctly, but not all the time. And so this is where they kind of know enough to be dangerous. And this is the area where you have to use your critical thinking to keep them on track. And we'll talk more about that. Now, what are they not good at? So I've found at least a few cases that they don't do so great at. One of them is just like iterating over a bunch of cases. They're just not great at iterating so much. So maybe do that more programmatically or manually. And they're not great at identifying a single piece in a larger context. Like if there's a bug, you say, hey, what's the problem here? They might confidently say, oh, this is your problem. It turns out that's not the problem at all. Or maybe they'll fix a problem but completely ruin another part of the code because it just doesn't work together and they can't quite see that. And they're bad at that. And then they're even worse at digging themselves into a hole. So if you're like, hey, that's not actually the problem's here, they'll say, oh, yeah, you're right. Let me fix that. And you're like, no, that's not it either. And it'll just keep going from there. So if you ever find yourself in that situation, stop digging. Another thing that they're just not great at is being honest. If you say, hey, I want to do it like this instead, they'll always say, hey, that's a great idea. That'll make everything so much better. Even if you say the exact opposite of what you said a second ago. So take everything with a grain of salt. So now that you know what your tool can do for you and you know what it's good at and what it's not as good at, you want to know like when should I use this and specifically what benefits are you trying to get out of your tool and what are some of the risks that you might face. So the obvious benefit is I want to go faster. And yeah, they help with that. But I would say that that's one of the lower level benefits that you get. So another big benefit is learning. If you're working with a language or a tool that's unfamiliar to you, it's a great place to get help from your coding assistant. And I have an example for this. So I had written a backend system that did all kinds of interesting things, but I wanted to demonstrate it, and I needed a interface that would just show it so I could demo this. And I didn't want to spend a lot of time on it. I didn't care if it was correct. It was probably going to be throwaway code anyways, but I just needed to show it. And it had a lot of features. And I was trying to figure out, okay, how do I do this? Do I have to get into JavaScript and React? Can I make like a terminal app or maybe just a command prompt type thing? Uh, and so I asked the AI and it suggested a cool option that I didn't really know about called Streamlit, which is for quick prototypes in Python. And this was great because it banged it out immediately. It showed me how to do all the features that I needed, and and it just worked. And it wasn't the best code, but I was able to immediately show something that demoed what the actual like backend code that I'd work on did, and I looked like a hero. So that was a great place to use them. But I recognized that a lot of our day-to-day code is not going to be throwaway code. It's going to be code that you need to maintain and you need it to be dependable. And you still want to get the benefits of these AI tools. So what do you do in that case? And I would actually argue that this is the best benefit. So if you've ever done pair programming, you might be familiar with this concept of one of the pair is like worried about the logistics, like actually typing out the code, getting the parens right, just calling things correctly, just the logistics and fundamentals, and not really thinking about how things fit, like the bigger picture. The other person, that's their job. Like they're thinking ahead, they're thinking about the patterns they want to use, the abstractions they already have, and how they're going to build this out and what to watch out for. And these are two totally different modalities. And it's really hard to do both of them in your head at the same time. So if you're working on your own, I mean, you're kind of forced to. But if you have your AI coding assistant, you don't have to worry about that logistics level. And you can just work at this sort of higher level of operation where you're staying at that level, thinking of the ideas. And I would argue that this lets you get even better level of code. Now, of course, the risk is if your AI is writing the code, what if it writes stuff that doesn't actually work? And what if you don't really understand it? And I had this problem once. I just asked the AI to do a whole feature for me, and then it worked fine. But later I had to add another feature to it, and then I had some performance problems, and I had to look at it closer. I kept asking it like, "Oh, this isn't working. Can you fix it?" And I got stuck in that whole problem that I mentioned. And I ended up having to try to understand the whole thing, and I just ripped it all out and rewrote it all from scratch by hand, which was really frustrating and also like ate away all the benefits that I got from using it in the first place. That's the wrong way to do it. We don't want that to happen. So, what is the right way? Now, do you know what's the thing that these AI coding assistants are the absolute best at? They make great rubber ducks. So, if you're not familiar with a rubber duck, what you do is you take a rubber duck, you put it on your desk, and anytime you have a question or a problem that you can't figure out, you turn to your rubber duck and you ask it. And no, the rubber duck's not some magical code oracle, but by the process of asking your question, formulating it, saying it out loud, giving enough context, you often end up realizing parts of it you hadn't thought of or explaining parts of it more clearly than you were when you were thinking about it in your own head. And you will find the answer for yourself. And this is what the LMs can do if you're working in the chat window, sometimes you don't even need a response from the LLM. I've asked my question, thought, hey, I think we should do it like this, and here's my whole idea, and it would be better like this. And by the time I finished explaining what I wanted to do for me, I realized, actually, that's not a good idea. That's not going to work. I need to do it differently. I didn't even need a response. But unlike a rubber duck, the LLM can respond to you, and they can even give you examples to look at. And so, in this way, you can have a conversation and push this idea forward and have a path of discovery that you're going down. And this is the type of work that I think is where you can get the most out of using the LLMs for maintainable code. And this is where you're applying that critical thinking. And so I'm going to show you some examples where I'm living in the chat window. And what I want you to look at when you see these is, first of all, the tone of voice that I'm using. Sometimes my colleagues will say that they are unsure what they should say, like how should they make the prompt. They don't know all the proper ways to write prompts, and so they think they're not going to get the best results back. And what I would say is you don't have to worry about that. Like the system prompt is baked into the tool. You just need to provide the user's prompts, which are, talking like regular people. You should have a conversation. Sometimes I act like I'm a junior dev talking to a more senior dev, and sometimes the opposite, depending on what kind of response I want. But just have a conversation. And it's less about crafting the perfect prompt to get the perfect response and more about the path of the conversation and the iteration that it takes to push an idea forward. This is an example that is pretty straightforward, and this is a case where I know exactly what I want to do. And so this is the most crafted prompt that I have. And the first thing is that I include the code that I'm going to be refactoring. And then I also include a commit that I had done that has the context of some of the changes that I want to apply. And the text of my prompt here is saying, hey, it's time for a refactor. Check out this particular code and also check out the changes that I've made. I want to use these changes to fix this algorithm. And here's the loose algorithm, and I give it some bullet points. But the most important part of this prompt, down at the bottom here, it says, take a look at everything and outline your understanding of the plan. So this is a technique that I'll do very frequently, is say, do you understand this? And of course the LLM doesn't really understand anything, it's just matching patterns. But I find that this is helpful for a couple reasons. First of all, it's going to encourage the LLM to respond with more of a conversation instead of code, which is helpful at the beginning. And it's also just going to make sure that it actually does understand. Like maybe I wasn't clear, or maybe I forgot to include the part of the code that shows what I'm talking about. I've done that before and realized, oops, I forgot to include it. But also, most importantly, it's kind of going to seed this conversation with the direction that I want it to go so that when it does start writing code, it's going to be more accurate. And then I also say, hey, here's what I want to do. Is there anything that you think might be an issue? Or is there anything that is unclear? So it responds and explains what it understands. It can't help itself jump into new code, and then it outlines a few of the issues. And I read that over and I see if it looks like it is right. And in this case, yeah, it got it, which is great. And I'm just having this conversational tone, and those points I wasn't worried about, so I said, don't worry about them and go for it. And it does it. And because it was just so clear, it was exactly what I wanted. I applied it and I was done. Okay, here's an example where I'm not exactly sure where I want to go, and so I'm going to explore a few options. And there's a few interesting techniques that came out of this one as well. So one of the things that I often will do, if possible, is include the tests. And also if I have any types, I'll include those as well, because that really helps the LM know what it's trying to match. But if you're starting with new code, new features, you won't have that. And so I do the equivalent of TDD. I have the LLM make some tests for me to begin with. And I spend the first half of this chat just going over these tests and having enough of a test base that both the LLM and I understand exactly what we're going after. And then I want to jump down to this point here. Once I'm happy with where the tests are, I start to think about how to do the implementation. And I'm unsure about the data structure. And so I do this pattern that I do frequently where I say, hey, give me a few ideas and give me the pros and the cons. And you can see it's done this, talks about some options, give me some pros, give me some cons, gives me some nice little representations that I might not have thought about. None of these actually had the answer that I wanted, but they made me think about some other options, and that happens frequently. And so I'm sort of struggling to express what I'm thinking, but I'm mentioning that I feel like there's a pattern for this, right? Like we don't need to reinvent the wheel. Is there a way to do this? And I'm not necessarily familiar with the Pythonic way of doing this. Maybe there's some tools that exist already. And so I'm trying to learn what's out there. And I'm saying, hey, this is ringing any bells with you. And this was really interesting. It tells me about an interval tree structure, which is something that I hadn't really heard about before and wasn't familiar with, but it sounded really cool. So it explained how it was and how you could use it. And I sort of understood it, but I wasn't sure if it applied directly for us. And so I asked it, like, okay, can you explain that more to me? And but also, importantly here, I say, can you explain why we need it? And this is me turning the LLM back where the LLM is playing the role of asking the questions, and I'm playing the role of the rubber duck. And you can actually see it go through and explain how it works and why it's great. And then there's this key moment right here where it realizes, after having explained how it all works, that we're actually unlikely to need this and we can use a simpler approach. And so it lands at ultimately what I ended up using. And with the tests, knowing where we're going, and this exploration of all of the options we could do and why we may or may not choose those options, I got essentially the entire module, and the code basically just worked and was ready to use. Okay, here's an example where I had to do a lot of hand holding for this one. So there was a bug in the code, and if you remember, having it spot bugs is sometimes something it's not so great at. So I describe what the bug is, and then I use this keyword of, do you see what I mean? I want to make sure that it actually understood what the problem was. And then I ask it for some ideas of what it's going to do. And it does catch on to what I am pointing at, but it solves it in a really not so great way. And so I say, hey, that's kind of ugly. Got any other ideas? And this is something I do frequently. After I get a response from the LLM, I'll ask, are you sure about that? Or, hey, can you do that better? Because a lot of times it's the second or third time that it turns out the way I want it. And then I also say, give me a few options and give me the pros and the cons. And so it does. And in this case, I actually liked the option that it suggested. And so I ask a question to clarify it, but we end up going with it. But it's solved one part of the code. There's another part of the code that could fit together with this really well, and it doesn't realize that. But because I'm following along and applying my critical thinking, I suggest it. And it realizes, oh, yeah, that's a great idea. That can make the code better. And of course, I knew that. That's why I suggested it. Uh, and it does it, but it doesn't quite get all the way there. So I give another suggestion, and it's like, oh, yeah, that's another great idea. And here's the thing, even though it just finished writing what I told it to, it didn't actually use it. And so I again had to say, hey, are you sure you did that right? Why didn't you actually use it? So I have to really keep an eye on it. But because I'm working through this step by step and I see each of the iterations formulate, I know what the code is, I know what it's doing, I've played a role in designing it, and the final code that I end up with not only works really well, but I also know how it works and can get in there and modify it myself if I need to. Here's an example of going through a design process on a piece of non-trivial code that I found particularly satisfying. So I had a concept in mind of how I wanted to solve a particular problem. But first I asked the LM how it would do it. I was curious to see if we would have similar ideas. And sure enough, what it suggested was pretty close to where I was, and we were on the same page, and this allowed us to talk about the ideas before jumping straight into code. And so I wanted to clarify a few parts of this, and I asked a few questions and got a few answers and realized that the code that we had available to us would do what the LM was suggesting. But then I also had an idea from another abstraction that we had available that the LM wasn't really thinking about or aware of, and how we could use that in combination. And so I mention it, and then I give it the opportunity to give me a response by saying, hey, what do you think of all of this? And I'm hoping that it might catch some issues that I hadn't thought of, but it didn't. It thought that that worked fine and gave me an example of what that could look like. And so, once again, just to be sure, I said, hey, do you see any issues with this? Sometimes the LM will say something looks great, and if you ask it again, are you sure about that? It will look through it more carefully and realize, oh, actually, here's some options, or some options of things we could change. But in this case, it outlined some issues, and they were good points to bring up, but really none of them mattered. However, as I was looking through them, I realized that there was parts of it that were convoluted, and there was a much better flow that we could do, and so I described it. And then again, I'm using this language like, do you see the difference? Do you see what I'm talking about? And I think that would work. Do you think that would work? I just want it to keep engaging in this level of the idea and less about immediately spitting out, here's what the code should look like. But it thought it was good, and it did give me code that represented what I said and then explain why that would be better. Seemed like we were on the same page, seemed like it did everything, so I said, bingo, make it so. And it did. It spit out an entire module of relatively complex code with recursive tree walking that worked like a charm right out of the gate. I hope that you found that interesting, and I hope that there were some techniques in there that you hadn't used before. And what I think is best about this is I'm not writing code. I'm thinking about code. I'm reviewing code. I'm exploring different pathways. It's not code completion. It's not write a prompt and fire it off. But it's this iterative journey that's shaping the code and shaping an idea, and the output is source code that happens to work. In this way, it's more like an artist working with clay and shaping it and forming it and adding to it and removing from it until it's the right shape. And this is a really cool way to work, and it's something that's only become available to us very recently. So I hope you've enjoyed this talk, and I hope that you can apply some of these techniques to get the most out of your AI coding assistant. Thank you so much for listening.